Hey everyone, it's Coding with Kareem, and today I want to make a video on the Singleton design pattern. The Singleton design pattern is essentially a pattern in programming that says if we want to instantiate a class, let's only have one instance throughout program lifecycle. So instead of being able to, declare a class or a blueprint and instantiate it however many times you want within your program, a singleton's purpose is that there should only be one instance throughout the whole program's life cycle. So in this file, I have an example of a very basic singleton. So I have the class singleton example. And as you guys can see, we have this singleton constructor, but instead of this constructor being public like you would typically see, so you can actually instantiate it with like the new keyword or other means, we actually have this constructor as private. So that means that outside of this class, we can't necessarily generate this singleton. It would have to be within the class itself. And then we have this static variable, the static variable called instance, which is simply just a pointer to our singleton class. And then we also have this get instance public static method that simply returns the instance. And then as you guys can see in the static or global section of our program, we actually instantiate the instance. So by the time any of our code in main is running, this instance already exists in memory. So this would be an example of an eager singleton. Um, if we wanted to do a lazy singleton, we'd have to change the code around a little bit, but just for purpose sake, this is what a singleton looks like. So as you guys can see, let's say we want to call the say hello method. The say hello method is an actual instance method, right? So we simply can't call say hello through means like so, just to visualize it, right? This wouldn't work, right? But what would work is us actually trying to get the instance from the get instance method. So if we were to do that, that actually returns a pointer to our class. And from there, we can use the error operator to actually call the say hello method. So this works fine, right? But let's say we actually wanted to, use classes like we are used to, and we wanted to actually generate an instance, right? So if we wanted to build a variable called s, and let's say we wanted to call the new keyword, we should get an error. And let's check what this error says. Singleton example at line 5 is inaccessible. So the reason why this is inaccessible is because this is a private constructor. If I made this public, this would work fine. So this is pretty much a guard to prevent us from generating more instances of this singleton, and which is why you typically have a private constructor and a public get instance method that simply just returns you directly the pointer, and it's guaranteed to return you the same pointer, unless two threads access it. But that's a different video for a different time. So this is just a basic example of a singleton. Keynote, I do have this static destroy method, and typically for a singleton, you kind of expect it to live throughout your program. So some people may say, hey, there's no point of freeing this memory. But as you guys can see in static, the program portion, we actually call the new keyword. So we're actually allocating this singleton on the heap. So you could just wait for, the program to end, process ends, and they'll free up, your memory manually, which should be fine. But for those who actually do want to free up their singleton or clear their singleton before program ends, you can also, utilize this method. So now that we looked at a very basic example, let's look at an example of something that I typically use a singleton for pretty often, which is any sort of logger class. So for this logger class, as you guys can see, we have this logger constructor. This actually simply uses the fstream to actually open up our log file, and this allows us to actually write to the log file. It also allows it so that if the log file doesn't exist, we'll generate one. And then we also have to include the append flag so that we can actually write to the end of the file. So this is just our private constructor. And then we also have this private method here, write, which simply just writes to our log file. The reason why this is a non-static method is because this relies on this actual instance field log file, which lives on the instance, right? And then like we saw in our previous example, we have this public get instance method that returns a reference to a logger. So this syntax is a little bit different than what we're used to. This is actually called a Myers singleton. So essentially, this singleton the memory does not need to be free. The actual object itself lives in static storage, so nothing's being allocated on the heap. So this is actually best practice, and I believe from my research, writing a singleton like this makes it so that it's thread safe. So two threads can kind of access your instance, and it won't generate more instances, which would essentially break your singleton pattern. And then we have a bunch of instance variables, as you guys can see. Debug, info, error, fatal. This is typically how I like to structure my logger methods. And each one just calls a write method, and it either passes in the debug string, the info string, the error string. So this just directly writes to our log file. And then, in our program entry point, we actually, get the instance, and we call the debug, info, and error programs, right? So let's actually run this so we can kind of see this in practice. Okay. So that ran. Let's take a look at our log file now. So it should be generated. We have this log.txt, which we didn't have before. And as you guys can see, we have, the debug line, the info line, the error line. So let's actually keep running this executable. And as you guys can see, it is continuously writing to this log file. So this class is essentially doing its job. So that'll be it for this video. I hope you guys were able to learn something. If anybody has any questions, feel free to send me a message. And like always, I'll leave a link to this code and to my GitHub lessons repository in the description. And I hope everybody has an amazing day. Goodbye.